good afternoon, good evening. This is Stefano Polidori from the ITU, and I'm pleased to welcome you to the second day of the symposium on the Future Network Car 2023. The first day of the symposium enriched us on current challenges faced by regulators to ensure the safety of automated vehicles. Today, we will continue by focusing on the automotive artificial intelligence, and I look forward to learn more from our excellent night of speakers. Before we start, let me remind you that all presentations will be made available on the website of the symposium. The symposium is being recorded. 2 chat boxes are available, one of which is dedicated to the Q&A only, and participants can submit their question at any time by typing the question in the Q&A box. Having said that, it is my pleasure to invite Mr. Michael Sena, who will moderate our session today. For the past 6 years, Michael has been an active member of the Symposium Program Committee, and I have learned a lot from his newsletter called The Dispatcher that explores the topics of automated and connected vehicles. I'm very pleased to welcome Mr. Michael Sena to this year's symposium.
Thank you, Stefano. And thank you all for attending our session today. And a special thanks to ITU and UNECE for sponsoring and organizing this unique forum where the latest advancements in vehicle technology can be discussed objectively without commercial considerations or company pitches. During the next 3 hours, our panel of experts will discuss the topic of automotive artificial intelligence, which is artificial intelligence applied to vehicle safety, services, and transport management. I guarantee you they will do a much better job than ChatGPT, or I'll personally refund your attendance fees. The generally accepted definition of artificial intelligence, or AI, is the application of computers and machines to mimic the problem-solving and decision-making capabilities of the human mind. What we have today are systems that are trained and focused on performing specific tasks, such as recognizing a deer crossing a road, distinguishing a stop sign from a yield sign, or making the connection between a ball bouncing on the road and a child possibly running after it. Automotive artificial intelligence, or AI, is a term that has different meanings depending on who is using it. For some, it means completely removing the human from the driving task and turning over control of the vehicle to software and sensors. For others, the goal of AI is to supplement and improve the human driver's abilities in order to make driving safer, offer new and better services, and increase the effectiveness of transport management. The latter goal, improving the driving experience, has proven achievable with AI that accomplishes one or a limited set of objectives. The former goal, removing the human from the driving task, has proven to be devilishly difficult because the car needs to drive at least as well as a human. This panel will present and discuss views on the current status of automotive artificial intelligence and the different scenarios and timelines for the implementation. Our objectives for this session are intended to meet the needs of a diverse audience. For those attending who will work on policies and standards related to driverless vehicles, to further your understanding of the issues these automotive AI-based applications raise over and above driver assistance systems that do not use AI, including data privacy, liability, and the development of effective standards. For those attending who will develop solutions for highly automated and driverless vehicles, to further your appreciation of how automotive AI-based applications will interact with humans, including drivers, passengers, and people outside the vehicles. Finally, we will attempt to identify the factors that are standing in the way of widespread adoption of automotive AI. I will be the moderator for your session. On our panel, we have Missy Cummings, who will be a keynote speaker from George Mason University, Bryn Balcom from Oxbotica, Junichi Hiroshi from Japan Highway Industry Development Organization, or HIDO, Jenny Lundahl from RISE Research Institutes of Sweden, and Jan Lerman, Vice Chairman of the OICA Technical Committee. I'll provide a more detailed introduction of each of our session participants at the start of their presentations. Let's have a look at how we've organized the session today. I'm going to share my screen. And I'll put that in presentation mode. So, brief introduction, Missy Cummings with keynote, and then we'll have 50 minutes of points of view, I call it, beginning with Bryn, Junichi, Jenny, and Jan. We'll have a 10-minute break, and when we come back, we'll have approximately 90 minutes with discussion with the panel members and the keynote speaker. You're encouraged to send in your questions using chat. I'm not sure we're going to get to your questions in our panel discussion. I'll be monitoring those, but the panel members will be able to respond to your individual questions. So I encourage you to, if you have questions, to write them in. I would now like to introduce our keynote speaker, Missy Cummings. Missy is a professor in the George Mason University Mechanical, Electrical, and Computer Engineering and Computer Science departments. She is an American Institute of Aeronautics and Astronautics Fellow, a former U.S. Navy officer and military pilot, and recently served as the Senior Safety Advisor to the U.S. National Highway Traffic Safety Administration. Her research interests include the application of artificial intelligence in safety critical systems, assured autonomy, human systems engineering, and the ethical and social impacts of technology. At this point, if we were live, I would ask you to welcome our keynote speaker with your applause. But here is Missy Cummings. Missy?
Thank you. You know, it is, I'm just trying to, I need an applause machine to kind of get me going. Yay! Good morning, everyone. I still haven't quite finished my first cup of coffee for the morning, so I'm still waking up a little bit. But thank you so much for inviting me. I always enjoy interacting with this organization. I find the discussions very meaningful. I like to have the international view on what's happening in the world because, you know, as most of you know, with the rollout of autonomous vehicles, whether or not we're talking about driving assist or self-driving, it's been different in different countries. And the US doesn't always do things the best or, in my view, the right way. So it's good to have other opinions. So I thought I'd start out by giving some lessons learned of while I was at NHTSA, you know, some of the lessons that I saw or, you know, kind of gleaned from the time that I was there about the autonomous vehicle community. And so I'm generally talking both about driving assist and self-driving, but when I'm being very specific about one technology, I'll try to be clear. So I think probably the first thing that I learned at NHTSA, absolutely the biggest thing that I learned is no one's wearing their seatbelts. It's just shocking. It's mind-boggling. Like the autonomous vehicle situation is a situation, except that, oh my God, at least in America, we're so dumb. We're so dumb. We're not wearing our seat. A lot of us are not wearing our seatbelts. So you know, somewhere around 40%. It's just crazy. Okay, so but in the world of autonomy, kind of in that same vein of like, what were you thinking? I actually saw a lot of bad code, like just bad coding. Like as a one of the departments I'm in, it's a professor of computer science, like really dumb mistakes, shockingly dumb mistakes, mistakes that every student makes. They're students though. And we expect students to make mistakes in coding. What we don't expect is that these mistakes then kind of emerge in safety critical systems during actual operations. Prior to me joining NHTSA, I always made the joke that I'm never going to get into a self-driving car that any of my students coded. After working at NHTSA, I'm not getting any self-driving car that anyone's students have coded, just because I see like some of the mistakes. And how did, and I think, you know, yes, individuals make mistakes. Human coders are humans, right? So why would we think that they wouldn't make mistakes? But I think what really concerns me is not so much that mistakes were made in code, although they are really, some of them were very basic mistakes. We did not have a layer of supervision and or testing to catch those kinds of mistakes. And that suggests to me that there's some immaturity in the community. And we're going to come back to that, because I think that if you're having really dumb coding errors express themselves in actual either testing or an operation in a real vehicle, it really should be a red flag to you that you're not ready for prime time, because you don't have all the safety checks and balances in your system. The second thing that I learned while I was at NHTSA was, in general, it's true for both ADAS and self-driving, but particularly acute for self-driving, cars do not have defensive driving capabilities. And what do I mean by that? You know, when I'm going down the road, I can see whether somebody's head is kind of tilted down, and you can kind of see when people they're trying to do the hider, fake the, you know, keep the phone under the dash, but, you know, sort of, you know, but you can tell. And whenever I see that in another car, I make sure that I give that car a very wide berth. I try to get around that car as quickly as possible, because I recognize that that person is not a good driver, and there's likely going to be a problem if this continues for any length of time. And so I adapt my behavior because of the perceived unpreparedness of the driver in front of me. So that's defensive driving. I'm just not seeing that in, at least I didn't while I was there. You know, it's not that cars can't, you know, it seems to me that the way that we're developing self-driving systems today, and to some degree driving assist systems, they're very rule-based. You know, if I'm coming up on a car and I've got a delta V of X miles per hour, I'm going to execute a passing maneuver. And there's not really a more, and of course this is more complicated and it's subtle, like, but what are all the problems that we could to imagine that would happen as a result of this? And you just heard in the introduction about, you know, the classic ball rolling in front of the car. Yeah, well, that's another form of defensive driving. It's having an imagination of what could go wrong in this scenario. And, you know, this is the power of human imagination, is that we can potentially very quickly dream up a bunch of scenarios that could happen. This person on the cell phone, they could go flying off the side of the car, they could brake too suddenly. You know, we can appreciate that very quickly, whereas that has to be expressly coded into an algorithm. And so if I were to make a plea to all the self-driving car companies and ADAS companies as well, as, look, defensive driving is a thing. You need to start thinking about defensive driving capabilities. And my advice would be to develop a unit that does that inside the company, develop self-driving capabilities in various high-risk scenarios. The third area that actually, of all areas, that really, really concerns me is because it's getting virtually no traction in any regulatory forum, and that is remote operations. No, I'm telling you, you cannot remotely drive your car. Now, there's two kinds of remote operations. There's remote assist, where, you know, maybe there's a human dispatcher sort of person who is connected through some kind of electrical umbilical cord, and they're helping cars resolve confusing signs or whatever. Okay, I mean, I'm not saying you shouldn't do that. Indeed, you should. That's remote assist, but remote driving is where I've got a steering wheel, I'm hooked, I'm doing rate control of the car versus some kind of, you know, drone control station, if you will. No, we should not be doing this. I have yet to see any company establish that they've got anywhere close to the kinds of latencies, i.e. the lack of latencies that would be safe for these kinds of operations. Yet in the United States, you know, and in some places around the world, companies are just stampeding ahead, getting venture capital funding to say that they're going to do remote driving. No, you're not. You're not going to do it safely. I just don't see, I don't believe it. And I don't believe it because I've seen nothing but snake oil and sleights of hands And, we have got to, as a organization, come together and recognize, and I'm pleading to the standards organizations, we need to set some maximum latencies. And by sidestepping the issue and avoiding it, the companies you're responsible, because these companies, they're not given any guidance and they're not doing their homework. So I'm not saying it's just the standards faults or the company's fault, but we need some guidance there, and the regulators need to step in. I'm pleading with states right now to give remote operators, that would be both remote assist and remote driving. Every single one of those people need to have remote driving licenses. If you're doing remote operations, even assist, you should have a driver's license. And you would be shocked at the number of people and companies who are designing autonomous technology who do not have basic driver's license. That's just for basic cars. If you're going to do a driverless truck, I believe that remote operator should have a CDL license. That's the commercial driver license for trucks in America. It is just inconceivable to me that, given all the special constraints that go around trucks, that we are not requiring licenses for people who are touching these vehicles remotely. So I'm on a campaign in the United States to turn that around. We'll see how successful, but I think I'm again pleading to everyone on this call, this remote operations, both remote assist, but especially remote driving, we need to start addressing this. This is the elephant in the room that no one really wants to talk about. So I kind of foreshadowed this before about the lack of a safety culture. That's another big lesson. I'm not saying all companies are guilty of a lack of a safety culture, but I'm telling you that there's a lot of companies with a lack of a safety culture. They tend to be more of the new entrants, the Silicon Valley-based companies, as opposed to the companies that have come from out of traditional OEMs who really understand. I'm not saying they always do the perfect job, but at least they understand what it means to have a safety culture and how to embrace the safety culture. I recently saw a deposition transcript that went viral around the internet, and this was from the head of Tesla's autopilot, who did not know what an operational design domain was, did not know anything about human factors, did not think that anybody inside of Tesla needed to understand anything about how humans interact with technology. And I'd like to remind you that Tesla has a driving assist system, which has killed many people because of that poor understanding between the human and the automation assistants. It is, I can't give you a better example of a company that has a serious safety culture problem. You have a senior engineer on your team that does not know what an ODD is. I mean, no, that should not be acceptable. This is bad. And I also think that the fact that not understanding that if you have a driving assist system that is there to support the driver, you don't understand how humans interact with this technology, you're really opening yourself up for a huge liability gap, because you are missing a huge component. If you're saying the driver is ultimately responsible, yet you have done zero research into what kind of distraction times, heads down times, hands off steering wheel times affect the driving performance, I think that you're really culpable. And that kind of speaks to my next problem that I have that really became very clear while I was at NHTSA. And that is the hyper competitiveness of the industry. It's killing the industry. First of all, not the more classic OEMs, but even so a little to some degree, people see NHTSA as an enemy. And my advice to companies is quit fighting NHTSA, work with them. NHTSA is an organization that is obviously there for safety, but they're also there to help companies move forward when they're struggling. NHTSA does not wake up in the morning and say, who are we going to shut down today? That is not what is happening there. NHTSA is very attuned to the fact that we want a healthy industrial base for whatever component of driving. And so companies trying to hide and be secretive and hide information inside the SGO under the standing general order under confidential business information. Look, this is not helpful. It's not helpful to the companies. It's not helpful to the industry. I think one of the problems with industry is they've been so hyper competitive trying to be the first one to a robo-taxi, that they now they're in a sunk cost bias. Now they feel like they must continue hemorrhaging this money and be the first ones there, because they do not want to admit in public, for example, that they're having emergency braking problems. Every single company out there, meaning they're doing a hard braking maneuver, which is unexpected and is causing problems. It is not just a Tesla problem. It is an every single company problem, but the companies do not want to admit it, and they don't want to share data on it. And I'm telling you, we are not going to solve that hard braking problem until we come together as a cohesive, at least an industry who is willing to share lessons learned. Nobody's asking you to share your code. What we're saying is you need to come together, because it's likely that we as a group could come up with a better solution than any individual company could alone. So I know I've complained a lot and told you, where I think the industry is going wrong. What in terms of regulations and policies, what can we do about it? So the idea of a type rating, which does happen in, at least in Europe, this is the idea of pre-approval before you're allowed to put cars on the road, either ADAS or self-driving. That doesn't happen in America, because we are self-certification. We self-certify, we allow companies to self-certify, and then we use recalls when that's a problem. So I suggested that we think about type ratings inside the Department of Transportation. I was immediately riddled with virtual bullet holes. I mean, that was definitely a non-starter. I was really a very unpopular person for even raising the idea of type certification, at least initially. I get that. I get that it would be a very difficult change in the United States, but I do think that, especially with the recent crash of, I think it was the 15th crash of a Tesla into the side of a emergency response vehicle. And this was in the United States, where the Tesla ran in full speed into the broadside of a fire truck and killed the driver, injured a lot of other people. Look, I'm not Tesla bashing. I'm just saying Tesla publicly said they fixed that problem when NHTSA started an investigation a year and a half before this most recent fatality. They didn't fix it. And over-the-air updates are difficult. And software is, you can't see the fix like you can in a physical system. So I am starting to advocate inside of the United States that we do a type approval for over-the-air updates that touch safety critical systems, because we can still self-certify. So for example, if a manufacturer wants to put an ADAS system on the market and it works great, fine, they self-certify, it works great. But if there's a recall and they're about a safety critical system, in this case, hitting a vehicle's broadside, which should definitely not be a problem, then there should be some kind of type approval. That would mean in the United States that we need probably some kind of third party to do code reviews, hazard analysis reviews, kind of look at test results to make sure. So it's kind of a hybrid between what the FAA does in America, which is type approval, and NHTSA that does self-certification. I think this hybrid approach, once there's been a recall for a safety critical system, I do not see another way for us to ensure that we can trust what companies say. And by the way, I'm not even saying that companies are trying to misrepresent it, because they probably did believe that they fixed the system. But code wrangling is hard. And I'm quite sure that companies, especially those who are under financial pressure, do not spend the time and money that they should to do test and evaluation. So I think without having some kind of umbrella over the head of companies, they're not going to do it. Lastly, I know I only have a few more minutes. Look, I'm now, no one likes me. Everyone from Tesla who likes Teslas hates me. And now I'm going to make sure everybody else in the community hates me. And frankly, I don't care, because I've seen so much dangerous interactions out there. We should not be advertising hands-free for any car. I do not care whether or not your ADAS system has driver monitoring, has two kinds of driver monitoring. It is very clear, at least in the United States, that when you tell somebody they can be hands-free, they equate hands-free with mind-free. And they are putting themselves in physical positions, like rearranging their bodies inside the cockpit of the car, like maybe turning like this or talking to somebody next to them, tucking their feet behind the seat. When something does go wrong and some kind of automated driving system kicks off, people are not physically ready to take over. I personally saw inside the standing general order set, you can see pedal misapplication all the time. When people are going for the brake and they miss and they hit the accelerator, they're not ready. I'm hands-free. I don't have to be paying attention, right? Well, I sort of have to be. I mean, I said I was going to be paying attention, but I'm hands-free. So I think that, and the SAEs heard me say this before, look, we've got to get rid of these levels. They're too confusing. People don't know when that they're supposed to be driving. People think when you call a car full self-driving, they think it can. And you don't even have to call a car full self-driving. When you tell your drivers they can be hands-free, they are being hands-free and mind-free. We need two levels. You're driving or you're not driving. That's it. There should be no other in between. And, we can argue about what would that mean to, what does it mean for you to be driving, not driving? I think I agree with Phil Koopman that the act of driving is that the threshold is whether or not you're steering. But we need to recognize that I don't care how cool these technologies are, by the way, and has anybody seen these surveys? Americans at least don't want these fancy technologies. The vast majority of Americans do not want self-driving cars and are leery of self-driving, of driving assist systems. So we need to recognize that trying to advertise and make cars that are hands-free makes people mind-free. And that is the most important thing that you want them to not do, right? You want them to keep their eyes and brain, not just gaze, you want their brain to be on the road. And so I think that this community really needs to rethink what we've asked out of drivers. They're going to be complacent, they're going to be distracted, and telling them that they can be hands-free is only going to make that worse. Now, I could be here all day. I could do an 8-hour workshop on all the things that make me crazy after spending some time with the government. And I really appreciated the time that I spent with NHTSA. I learned so much, but I now will yield the floor so that we can get to the other panelists, and then we can discuss this more in the discussion section. Thank you.
Missy, thank you very much. It was hard keeping up with you, taking notes. We have a lot of questions that we're going to deal with in the panel discussion. Just one quick one. Do you feel that in the United States that there is some forum where these kinds of issues can be discussed? Is there some place where everyone could come together and say, I've got this idea and this problem? Or is it just coming to NHTSA and NHTSA kind of acting as the supervisor, as the goalkeeper?
Well, I would say that, the forum that we typically do this either would be the Transportation Research Board meetings in January in DC, or the National Academy's automation meetings in the summers. So those would be the two venues I think that would be the most common. And I also think that the issue with NHTSA is tricky. Like what their statutory authorities are don't cut across all the issues I raised. For example, the licensing issues are squarely at the states for the remote operators, right? So I'm working with several states to talk about how to institute a new kind of licensing program for remote operators. And that's not inside of NHTSA's bailiwick. I also think there's a fight brewing over who licenses the technology as the driver. Some states say that they should. It's probably more of a NHTSA responsibility, but it's not clear who owns that then, right? If states license the driver and the driver is autonomy, yet NHTSA regulates technology, you can start to see where that fight is. And it's it's confusing. And I don't think that may end up, at least in the United States, be decided by a court of law. So I would tell you the answer is but that was a very long answer to say there is.
No, that was good.
And that is why I like to come to these organizations, which sadly do not have as much US participation as I would like. So indeed, maybe one specific request out of this group, and I'm happy to help, is how can we raise the US participation in these kinds of events?
Yeah. Okay, Missy, thank you very much. I'm going to introduce Bryn Balcom. Bryn is autonomy systems and regulatory expert at Oxbotica. He is the founder of the Autonomous Drivers Alliance and previously served as Chief Strategy Officer for RoboRace, a motorsport competition for human and AI drivers. He's a chairman of the ITU-T focus group for AI for autonomous and assisted driving. Welcome, Bryn.
Hi, Michael. Thanks very much. So hopefully you can see my slides. And if so, I'll continue. So thanks very much for the invitation to speak today. I'm going to give you a whistle-stop tour of the last 3 years of activity that we've had on the ITU focus group that Michael just mentioned. So we started 2019. The proposal came up at the AI for Good Summit. We closed last October, and now our work has been taken forward to create a new ITU recommendation, so an international standard. And I'll talk a little bit about where that standard sits. So Missy just mentioned kind of like the different parts, if you like, of regulating safety and the sort of pre-approval, so the ex-ante type work. Can you predict what that behavior is going to be? Can you make sure it's safe before it goes on the road? There's a lot of work and regulation going on that within the UNECE. The activity of the focus group actually focused on the sort of ex post, the sort of after the event behavior, so the explainability. So once these vehicles are deployed in the real world environment, how can you continue to monitor their safety? How can you explain any incidents that might occur? In order to do that, we had a motivating case study, which was we called the Molly problem, which was really focused on a young girl crossing the road alone, hit by an unoccupied self-driving vehicle. So that meant there were no eyewitnesses. How in that situation, or what should the AD software be able to explain about what happened, and what would be the expectations of the public? So we did an international public survey, had over 500 responses, looking at almost 3 different areas. So situational awareness, hazard awareness, what sort of mitigating action was taken. And then the focus that we had really was to develop this sort of behavioral assessment, what's the outcome? So in terms of situational awareness, the very basic things about the time the collision occurred, the location of the collision, the speed at the collision, 98, 99% of people were saying, yes, of course, we should record that type of information, should be able to recall that for explainability purposes. Similar high levels of percentage for when the collision risk was identified, if Molly was detected and when Molly was detected, if Molly was detected as a human, so classified as a human, and when Molly was classified as a human, which kind of affects the risk profile. And then the same for mitigating action, same percentages. A recall of whether mitigating action was taken, when the mitigating action taken, and what the mitigating action actually was. So there's clear expectations from the public that the behavior of an automated vehicle needs to be explainable. In the technical report 1 from our focus group activity, we really focused on these 2 initial bits, the sort of world model representation in which we can capture the awareness and the mitigating actions, the sort of arrow that kind of links like the communication protocol, and then the outcome, which was sort of focused on metrics and thresholds, will be classed as future work. So it was somewhat out of scope for where we were, given the pandemic and other things that were going on at the time of the focus group. To give you a system kind of view, if you look at the left-hand side, we're talking about an automated driving system. Outside of that box, you see the physical world. It makes an interpretation of the physical world using its sensors, creates an internal digital representation of that, including vehicle dynamics, localization, object perception. At that point, we then say, okay, can we take that information and then share that to an alternative system, an external system, focused on an AD safety assessment. And within that system, you're using this world model representation and running that through a set of metrics with a set of thresholds. The bit in the middle, this sort of standardization of how do you communicate that information from all AVs, was the focus of our activities in the ITU focus group. I'll start with a world model representation, just so that people have an awareness of that. So that's basically the blue bit that you see there before it's communicated. And the world model representation is the sort of spatial, temporal dimensions of the physical world. You know, what have you been able to catch about where you are, where the other objects are, relative to the infrastructure, relative to the other road users. And if the world model representation is really that foundation for the AD software decision making, and then the resultant vehicle behavior in the physical world. So what we were looking at was specifying a common format in which that world model could be communicated. Now, I would say that the world model is also a kind of universal language with all other human drivers, with road accident investigators. So that kind of time and spatial relationship is what's used to actually analyze and understand what happened. So what we looked at was, okay, well, where can we also find some common references for world model definitions? And it became clear we established a number of liaisons with other standards bodies, in particular with FNC. And we looked at what they were doing in terms of cooperative, connected, automated mobility. And the standards that exist around that, like a common data dictionary. So we've aligned with the data frames and data elements of the common data dictionary. And that means that the models that we're using, world models we're using, will be compatible with cooperative awareness messaging, vulnerable road user awareness messaging, collective perception. So you're starting to see now that we're not really focused just on automated driving, but the connected, cooperative automated driving. And having some standards that kind of sit and are harmonized across those domains is incredibly valuable then for cities around the world. So type of data for the ego vehicle or for other road users, you know, headings, speeds, directions, accelerations, you know, yaw rates, curvatures. For objects, object IDs, the time you detected it, its location, its velocities, accelerations. So basically how things are moving through time and space, and then what confidence do you have in those measurements that you've made. So the output is a common world model representation. All AD software systems using this specification would have a common model output, and that's what the standard's for. And this doesn't imply that the internal representation has to be changed. That can be proprietary. It's just a method of communicating that outside. The second part of our standards work was really focused on the communication protocol. So great, you've got the world model, but how do you share that? How do you share that in various different ways, whether that's in the same operating system, on the same compute hardware, on the same vehicle, but maybe on a different compute platform, or using remote wireless networks to communicate with the edge of the network or to a public or private cloud. So we were identifying various different protocols throughout the life of the focus group. The one that we ended up selecting was a new protocol called Eclipse Zeno, which is a communication middleware that can be used over the Ethernet, time-sensitive networking, Wi-Fi, 5G, 4G networks, and can be deployed for cooperative, connected, automated mobility. It enables data to be published. So effectively the AD software can publish the data, and then it can be subscribed to by any subscriber. In this case, it will be the AD safety assessment system. And then it also enables the AD safety assessment system to query the world model data. Even if it's not been shared previously, it can actually make a query onto all the geo-distributed resources. So all of the vehicles or all of the instances on the edge of the cloud. And then that can trigger local computations and make data transfer more efficient. You're asking for specific things. And that could be, were you in this location at this time at the event of this type of incident, just like we have when humans report information about certain events. So that type of querying could make things very efficient. Again, the output is a standard communication protocol in JSON Bison sort of encoding according to Eclipse Zeno. Every system would then, that is applying this spec, would have the same communication mechanism. But that doesn't restrict, again, how the internal communication is handled within the autonomous driving system. So that's still left completely free and open. Throughout this work, we were aligning closely with the activities of UNECE, WP29 GRVA, focused on autonomous automated vehicle testing, particularly as time went on, the sort of new assessment and test methods. So this really focused on in-service monitoring and reporting, and that's something that's made it into the sort of EU regulation, with the purpose of that in-use monitoring and reporting is for like safety confirmation, scenario generation, and then safety recommendations. But basically it's that ability to capture information about how the vehicles actually behaved in the real world, compare that back to how it was intended to behave, and then identify discrepancies either in the performance relative to how it was assessed or to actual harmful outcomes that might have occurred, and then generate the evidence required to go back and do that assessment that Missy was talking about. Okay, what failed? Has it been fixed before you can get back onto the road? So that was kind of like a whistle-stop tour, and I'm looking forward to the discussion. The focus group is closed, as I say, but the activity is now being continued within study group 16, within the ITU, and then that's open for participation through your government agencies. So Michael, hopefully that's the time, and I hand back over to you.
Super. Thank you very much, Bryn. Quick question. Has there been any participation in these activities that you were describing from organizations in countries that are not part of the type approval process?
Yeah, so we had interactions with companies in the US. We held a couple of workshops that were internationally based. So yes, in the US, and yes, over in Singapore, for example. And that ranged from universities through to AV companies to OEMs, also with standards bodies based over in the US, particularly with SAE, IEEE as well in certain areas. So yeah, there's been a wide participation from a lot of stakeholders over the last 3 years to get to this this outcome.
I'm going to ask a follow-up question, and then we'll get more involved with this in the panel discussion. In any of these activities that were outside of the type approval countries, did anyone say, gee, it sounds like we should really be involved in type approval?
I think it's more of a question of, I wouldn't say specifically on type approval. I would say I've experienced the same thing Missy has in that, do we want to share data? And there's that hurdle to get over, which is like all of our data is private. We don't share our data with anyone. We don't explain anything to anybody. Give us a license to be on the road, but we don't expect you to impose anything upon us by having that license. And I think when we first started to look at this, there was a lot of get us on the road, which was the sort of pre-approval stage, if you like, or the approval stage. What's become very apparent is that governments will not accept that as the only mechanism without some form of in-use monitoring. Some form of, okay, yes, we gave you the license to be on the road, but now we need continual safety assurance while your vehicles are operating that they are performing safely. And that is something that is kind of, you know, somewhat new, but it's going to be the area that people will focus on more and more, I think, as we get to scaled deployments.
Okay, great.
If we get to scale deployments before Missy comes back at me.
Okay, Bryn,
looking forward to the discussion.
You can hear the applause. Thank you very much.
Thank you.
And now I'm going to introduce Junichi Hirose. Junichi, can you?
Yeah.
There you go. There you are. Great.
Okay.
Junichi is the Principal International Research Fellow and Senior Researcher at ITS Create Division of HIDO, the Japanese Highway Industry Development Organization. He's been working on creating several international standards in the area of ITS within ISO TC204 since 2003. Currently, he's the convener of ISO TC268 Subcommittee 2, Working Group 2, International Standards for Sustainable Cities and Communities, Sustainable Mobility and Transportation. Welcome, Junichi.
Thank you. Can I share the screen?
Yes,
Okay.
we can see your screen.
Okay. Let me introduce the today's presentation about the ISO activity in TC204. I have the project leader of this document, and that's already published as the technical report. And this the technical report 5255-2. -1 is a role model, and -2 is gap analysis for the safety of low-speed automated vehicles. And this is the only technical report, and this just to help the automotive industry and also the service provider to create and deploy the actual low-speed automated mobility in the smart cities. And this document describes the gap analysis of the safety environment and for the low-speed automated driving services, LSADS. And role model is also in TS technical specification 5255 part 1. And also this is described this part describes the AI role for the functional model and service application for LSADS. The LSADS safety environment by using AI, AI is artificial intelligence, which provide the safe LSAD automated driving function. And also the AI is used in the vehicle and also the back office. Back office support all the fleets. And AI should be educated by the rich big data. And if the AI meet the situation that they haven't the experience, human intervention should be taken place in the highest level. Safety operational concept using AI, as I said, that the AI should be premature or matured ones, and the premature one should be educated with the support from the back office AI. This is the concept of this safety role using AI. All the vehicles AI is backed up by the back office AI, contributing to the entire LSAD fleet safety operations. And also the education of the safety function of AI should be designed to be educated constantly by rich and properly structured big data. As big data should come from the smart city infrastructure sensors and also vehicle itself. Many sensors are built in the vehicles. And the first-hand safety decision making is taking place. So the necessary proper and correct decision making becomes possible. Education sharing among AIs, well, if the one fleet AI is educated by back office AI, all the AI fleet should be educated by back office AI. And so all the AI should be matured level, same in the mature level. And also supplemental safety support function of LSAD system services. It's also been understood that in recent years that the most appropriate teacher of the getting premature AI to mature level is the human brain. As Michelle said, that the human is the most maybe reliable safety driver at this moment right now. So the in the highest level, the human brain should be intervene to the safety function. As this figure showed, that the back office AI should request support and educational support from the human. at the last level of a safety function. And role of human is in this slide say that the for the ODD level 4 and 5, say J3016, the various dynamic human interventions are assumed to occur on an on-demand basis, as previous figure shows, depending on the human maturity, the maturity of the AI mounted to the LSAD vehicle. Use case example is shown here. This case, the lane 1 is ongoing lane, and lane 2 is the main lane which vehicle is traveling. And the center line is solid, so it means it's do not cross. And if there is a work zone in the middle of the lane, and the temporary traffic signal show that the red, which means stop. But worker at guiding the big traffic said that flags to proceed. It's a much complicated situation, and the AI could not solve this situation. So the human intervention should be taking place in this one example. So if there is in this document, there's also many use cases shown, and if you're interested in, please contact me so I can help you understand and also support you deploy the low-speed automated service in your smart city deployment. Thank you very much.
Thank you very much, Junichi. I have a couple of questions that I think many of us who are watching and listening would probably have as well. You used a few terms here, and I think it would be helpful if you could be a little bit clearer on what you mean by premature AI and mature AI. What is premature AI?
Yeah, premature AI, because the AI is becomes smarter when the more essential and structured data is given to the AI. It's machine learning stage. So if the AI, for example, in this situation, the premature AI could not understand the situation. But if they want, once the human educate this AI, in this case, you can follow the worker's signal, flag signal. Then this AI becomes a mature AI in some certain level. So yeah, it's a word meaning mature and premature should be explained in the presentation, I think. Thank you very much.
Okay, and then you use the term back office AI. So is this distinguishing between the AI function that's on board the vehicle and what's happening off board the vehicle? Is that what you mean by back office AI?
Yeah, back office means the control center or fleet management center, which is connected by the communications to the each vehicles. So AI, vehicle AI can communicate with the back office AI through the communications, probably 5G, and also the back office AI should be the most highest position in this layer. And other than that, the human is on top of that layer. So if the back office AI cannot solve the situation, they can ask for this support from the human.
And so my last question, just before we move on, when you when you refer to human, is this human in the back office or is it human in the vehicle?
Human in the back office or human in the vehicle or any other remotely controlled driver or any case. So there should be communications between them and also the communication center between the back office and also that the human is with its location.
Okay. All right. Thank you very much, Junichi. We have more questions when we come to the panel.
Thank you.
Thank you. Great. Okay. And now I would like to introduce Jenny Lundahl. Jenny is a senior researcher and legal expert at RISE Research Institutes of Sweden in the Mobility and Transformation Unit. She works with many issues related to policy and regulatory innovation for mobility and systems where AI applications for vehicles and transport systems is one part. Welcome, Jenny.
Thank you. I'll try to share my screen. Can you see the presentation? Oh.
Yes.
Sorry. So I will tell you about the research project in the field of automotive AI, and it's called AI Aware Scale Up. And my name is Jenny Lundahl from RISE. So in this research project, the aim is to develop an AI algorithm for accident risk prediction. And the aim is to use AI to predict events in traffic and prevent accidents to occur. And we see this as a vehicle-related application of AI with the potential to take us one step closer to Vision Zero, that no one should be killed or severely injured in road traffic. There was a previous AI Aware project, and it has been extended into this second phase, AI Aware Scale Up, hence the name. And the time frame is from September 2022 to December 2023 this year. And the funding is from Vinnova Drive Sweden. I'm obligated to say that. And the idea is to develop AI solutions that can be used to predict events in the traffic system and create a safer traffic environment. In addition to RISE, the partners are Volvo Cars, Sensiact, Carmenta, HERE, and the Swedish Transport Administration. And there's a link below to the project website. So to put this in a context, I will give you some key facts about road deaths. Every 24 seconds, someone is killed on a road, and worldwide there are 1.3 million deaths every year on the roads. It's the 8th highest cause of death for people all ages, and it's the #1 killer between 5 and 29. In EU, there were nearly 20,000 people killed on the road in 2021. And that's 45 people per million population. And the fertility rate ranges from 20 in Sweden to 92 persons per million. But what is positive then? Road accidents and road injuries can be prevented. That's our starting point for this project. And so the challenge and our what if question is, can we predict the traffic accidents by using available data and take preemptive measures to avoid accidents? So can we prevent traffic accidents from happening, or at least mitigate their impacts? So this AI solution, it should be used for predictive awareness in a smart city context. The project establishes a solution for data collection and fusion to feed these AI algorithm to issue accident risk alerts to warn the driver. Accident risk alerts are dispatched in real time to connected organization. And by this, we will show the potential to prevent accidents. And we use a collaborative approach between traffic authorities and traffic management providers, map and location data providers, and OEMs, and RISE as a research partner. So the real-time data streams and static traffic system data are fused through the algorithm, producing a predictive accident risk alert. And data includes road attributes, weather, traffic flow, road friction, accidents, and other hazards. And also interfaces allowing for additional data sources to be utilized, such as other connected vehicle fleets. So the idea is to add more data and more data sources. Here you can see some pictures from accident risk alerts in use. Please don't ask me about these pictures because I cannot really give the details here. But as you see, a map at the right with different layers for different attributes, and the accident risk alert warning the driver at the left. And this picture here visualize the collaboration or the collaboration structure, and who has which data in this structure. It's both the project partners, but also other actors which the project collaborates with. So in this phase, the second phase of AI Aware, we build and scale up the results from the previous project. We have added new data collection sources, and also because this AI Aware application, it was developed in Sweden with data available in Sweden, but we have now added California as a new geographic area. And tests will be scaled up and public demonstrations will be made both in Sweden and California. And we will also arrange bilateral workshops with participants from Sweden and California on data exchange and to ensure two-way knowledge transfer, and also to discuss policy issues. And this is more my part of the project, the policy perspective. We will do a bilateral policy investigation where we will explore policy issues regarding access to data and data sharing, and also handling of privacy-related issues. And we will investigate differences in policies between Sweden and California, and also federal law in US where applicable, and try to identify the main differences and similarities between the two geographies here. And an important research question is access to the relevant data to train the algorithm to make reliable predictions. And we have only just started this part of the project, the policy part. So we don't have even preliminary result yet, but we think it's a challenge that the data is often found in silos. So in Sweden, we know about our data, and in the US, they know about their data. And I think we will well, on the surface, we may seem quite similar, but I think when we scratch the surface, we will see that there are differences. And so a big question is, can we get access to data for this AI application, which was developed in Sweden? Can we move it to California and get access to the data needed there? That is a big question. And also, how can we also protect personal data and get still all the benefits from data sharing? So this was my last slide. Thank you. And please contact me if you want to find out more.
Thank you, Jenny. Well, we're going to find out more when we get to the panel discussion. But there were two questions I had. One of them was why California? Now, why not Pennsylvania or Boston, Massachusetts? What was so neat about California?
I'm not really sure, actually.
Okay.
I know that Volvo Cars is one of the project partners, and they are interested in California.
Sure.
Yeah, but that's the only reason I can think of.
Okay.
I was not involved in that discussion.
Yeah. Well, they've got a special research group and have had for quite some time in California. The other question, I think, and I think we'll bring this also into the panel discussion. How do you ensure that all of those alerts that are coming to the human driver, assuming that there is a human driver there, don't distract him? I mean, there's plenty of information that comes into BMWs and Volvos and all kinds of cars today about traffic alerts or hazard alerts. But right now, what you're saying is that we're going to send information where the driver may or may not necessarily use this information because it's not clear that it will end up being an alert. It's just more information. How do you ensure that there's not too much information coming to the driver?
That is actually an open question in the project to find out more about how will the driver perceive the alert messages and respond to those.
Okay.
And we also have a similar project with the exact same question.
Mm-hmm.
We have done interviews with the driver recently in another project with not the same application, but for another application, geofencing, a geofencing solution with messages to warn the driver to lower the speed over a bridge when having a very heavy load on the truck.
Mm-hmm. Okay, thank you very much, Jenny. We'll see you in the panel discussion. Now I would like to introduce our fourth and final panel presentation. Jan Lerman. Jan is the Regulatory Affairs Coordinator for Automated Driving at Volkswagen and is Vice Chairman of the International Association of Automobile Manufacturers Technical Committee. Since 2020, he represents the international automotive industry in the areas of ITS, AI, data, and vehicle communications within the UNECE. Welcome, Jan.
Thanks for having me here. Do you hear me well?
Hear you well.
Very fine. Okay, so I'm just trying to show my screen, and you should see my presentation right now.
We see your presentation.
Very nice. So I want to show you or to introduce a little bit to our view on how technical regulations cover the partial use of machine learning today. As we heard a lot of great presentations right now, but being a little bit more reserved to artificial intelligence. Maybe this one here brings the artificial intelligence in some kind of better light a little bit, because something is possible and it's still covered. Let me begin with the two definitions I use here. So the artificial intelligence itself is a set of methods of or automated entities that together build, optimize, and apply a model so that the system can, for a given set of predefined tasks, compute predictions, recommendations, or decisions. I'm doing this here and now just to pick up people which many may be not aware of it. So sorry for being boring for all the experts here for a second. And machine learning is a collection of data-based computational techniques to create an ability to learn without following explicit instructions, such that the model's behavior reflects patterns in data or experience. So why do I do this? Because I use the terms in different ways in the ongoing presentation. What is the status quo today for maintaining vehicle safety? Software updates had to be made in the past in the maintenance center during regular service or recalls. So no feedback from the vehicle in the field was given to the manufacturers directly. It was just by finding issues and then making some kind of recall. And the time to market for a vehicle was depending on the time to redevelop the software, then to write the software code, to test this software if it's appropriate and safe, and the time until all affected vehicles had visited the garage to get an update of this new software. For the use of machine learning in maintaining vehicle safety, the vehicular communication enables the manufacturers to get field data from vehicles. So an artificial intelligence or machine learning algorithm may accelerate the processes regarding redevelopment after a report of some findings and issues and errors, writing the software code, and maybe doing the virtual testing according to tests it was giving according to regulations and laws. The vehicular communication allows it to send an update over the air, so vehicles must not come back to the garage, and the manufacturers can respond much faster by improving or expanding in-vehicle features and maintaining the cybersecurity and the safety of the vehicles. When we come to artificial intelligence and technical regulations, we have to derive between functions that are non-type approval relevant, which may be infotainment, speech recognition, or comfort functions. And the other we have is the type approval relevant, which are mostly safety relevant. It is steering, brakes, engine, and exhaust gas after treatments. It will be driver assistance systems and automated driving functions in the future. So when we introduce machine learning to the type approval process, according to the 1958 agreement that Missy was mentioning very well a few times, then we will see that there's a lot of things covered. So just to pick you up on the technical regulations, these are, according to the 1958 agreement, are defining a harmonization of minimum performance requirements and safety to be fulfilled by a vehicle in order to be certified with the type approval. That is accepted in 56, or to be honest, it's now 59, to be honest, member states, and therefore reduces efforts to bring vehicles to the market. So the whole type approval system with the software updates and cybersecurity is today some kind of circle. So once you've gained your, or you received your certificate of your software update management system and your certificate of your cybersecurity management system, according to the UNR 155 and UNR 156 for the software update management system, then you are able to start, develop, and bring your vehicle to the market. So then, after the schematic development of the function, the software code will be created. This is how it's done today. The software must comply with all the laws of the market in which the vehicle is sold. So it must comply with international harmonized and national regulations, as well as international quality policies. After the fulfillment of all the tests, the authority grants a system certificate, which is part of the whole vehicle type approval. The vehicle may then be placed on the market as it is compliant. So if the vehicle software sends new findings to the manufacturer can use the data to develop, program, and transfer an improved version of systems or functions to the corresponding vehicles. So as you see here in the diagram, we will derive between, is it a type approval relevant software update or not? And this is the first appearance of the RxS Win here, which is made within the UNR 156, which is a software identification number. So you may that know from vehicle identification number, where you can particularly describe one vehicle with this number. This is the same approach for software, where we can originally derive which software was on which vehicle and when was it type approved and when did the software go on the vehicle and what did it fix. This is all described in the UNR 156. This whole process is monitored by both a cybersecurity and a software update management process according to the UNR 155 and 156. And in terms of conformity, there's no difference whether the software is written by a human or machine learning algorithm. So for just creating the code, it is no difference if it's done by a machine learning algorithm or if it's done by a human being, because we have all the testing afterwards to bring it on the market and to get it type approved. So software, whether it is created by machine learning or not, will be tested prior to deployment according to comply to all related laws, regulations, and policies. And any update to systems in the market will need to follow the process defined in a software update management system. Thank you for your attention.
Wow. That's a lot to take in, Jan.
Yeah.
You've described a terrific process.
Yeah, I tried my best to make it short without explaining the whole type approval process.
You've done a very good job. That diagram really does say it all, but I think it takes a little bit of focus on it.
Should I show it a little bit?
No. We'll get. Okay. I'm going to ask you to probably bring it back when we do have our panel discussions. But what you've said in a kernel, I think, is it doesn't really matter who's doing the coding, as long as the testing of it is done afterwards, and the testing within the type approval process and the process that you've described should be robust enough to ensure that the systems are working. As I also understand it, the AI part comes in when the system is monitoring itself in use, I assume. After the tests are made, system goes into production. I mean, the car goes into production, it's on the road, and now it's got to monitor itself to see that things are working properly. Do we also have an AI function in there? And if so, what do we need to do to ensure that that AI function is performing properly as well?
For the first explanation, I think if we use an AI for that, so we don't need to use an AI, because on the other hand, we're doing it right now. So we're protocoling issues and findings, but we do it inside the car. So if you go to the garage, it will be read out via the OBD interface. So just copying that to vehicular communication and sending that update over the air, doesn't require an AI.
Okay.
But if you would use an AI for that, then it must be clear that this AI is just monitoring, is no correct connection to any actors or something like that. And even then, as I just showed, and maybe I should have showed it a little bit longer in my chart, there is a process step to review the reported issue. So
Mhm.
is it really is it an issue, or was it a mistake? Is it just from one car? Is it from more than one car? So there's a kind of sorting out if this is done as well with an AI. So then you somehow disrupt my presentation, because then we have everything with the AI and no one's watching. So
Yeah.
at the end of the day, I think if we use an AI for recognizing issues or not, even that must be monitored behind that. So like you introduced with ChatGPT, you can let an AI do some work, but you have to monitor the work
Mhm. I think
for the time being.
Missy, yep, I think we all agree with that. Okay, thank you very much, Jan. We are now going to have approximately a 10-minute break. You'll see on the screen that it'll be a countdown, and when when we come back, all of us will be on screen with our videos on and with our mute buttons off. So we'll all be able to participate as in a real, honest to goodness panel discussion. Okay, have a good break. Thank you. Well, we've got almost 90 minutes, and we have a lot of questions. I see that there have been questions that have been posed to each one of the panel members, and I think you've answered many of those. And I've taken a look at some of them. Some of them look pretty interesting. But as you know, I've prepared a number of questions for you, and I'm going to start with you, Missy. You recently said in an interview with Professor Alan Kornhauser, he's here, he's listening, that automated systems are, quote, up against the cognitive limits of humans. Drivers will not pay attention if they think the car is doing a good enough job. Even though they have their eyes on the road, their minds are elsewhere. You mentioned this in your talk today. How should AI applications interact with humans to ensure that they are engaged in case they have to take over the driving tasks? What should be the guidelines and defined limits? I know it's a big question, but I think
that's
it's a
big
good place to
question.
start.
Yeah, and I haven't really had enough time to really break down. I want to talk about the cognitive limits of people in driving assist systems, but also cognitive limits when humans are interacting around self-driving systems, because I think this often gets overlooked as well. Mm-hmm. So in driving assist systems, we have a long established history in aviation that if the automated systems perform pretty good and but not reliably well to what we would consider to be 10 to the -6 or 10 to the -9, whatever minus camp you're in, mm-hmm. Humans will have a tendency to give up control authority very quickly because the automation seems to them to be performing in all the ways that it should. And indeed, we see plenty of YouTube videos of people with Teslas like, wow, my car went, 3 miles, on a bright sunny day down a wide boulevard and drove itself. See, it's awesome. We're ready for self-driving cars, right? So humans make really bad assumptions about the overall capabilities of a technology based on a small amount of data. And then, of course, when you tell them that they can go hands-free, they relax, and they want to relax in a number of ways. And even though they think that, they've been told they've still got to pay attention to the road, and indeed, maybe the camera is making sure their face still is forward. Just because your face is forward we've all been there. You can have your eyes on the road, no automation involved. You can be listening intently to the radio or be thinking about the fight that you had with your significant other last night, that you blow right past the exit that you intended to turn off on, right? I mean, that is just the way that the human brain is wired. You have a rich space of interaction in here without a phone, right? And so we will find people, you know, and then of course you're tempted by the phone, or kids in the car, or you've got an infotainment center that, you know, defies, you know, anything that we have in the space program, you know, the ability to bring up all sorts of great information on your car. And so for most of the catastrophic accidents that we see, you know, there are some egregious distractions, people playing video games, for example, but then there are also really minor distractions. There have been a couple of high profile Tesla cases where it wasn't clear at all. I mean, a person just may have had their attention deviated for just a couple of seconds, and that was enough so that the car did not realize what was happening, and then, you know, chaos ensued. So I think that we have to appreciate that by telling people hands-free, you know, if you give people an inch, they're going to take a mile, that is what is going to happen with hands-free technologies. I think, and then of course, if the technology, even with LiDAR in the car, and people want to say, well, look, what if I have LiDAR in the car that does obstacle detection avoidance? You know, I mean, that's maybe a little bit better for forward collisions, but that still is no guarantee that the autonomy is going to perform at that 10 to the minus 9th level, because guess what, LiDAR doesn't work in with there's moisture in the air. You get degraded LiDAR signals, and I think one of the problems that people forget is degraded signals are worse than no signal, because if you have no signal, you can communicate that to the driver, but if you have a degraded signal, the system doesn't know. So I want to set the driving assist aside to say, we have another problem brewing, and I'm going to relate this back to our hard braking events. In self-driving scenarios, when you look at the NHTSA standing general order, you see that the bulk of collisions are rear end collisions. And some of those are going to be just people were following too closely, and they shouldn't have been. But increasingly, we're starting to see that the rear end collisions, a significant number of them are caused by hard braking, meaning that the car in front of you, which was an autonomous car, put on the brakes in a situation that was either unexpected by the driver behind, or so quickly that humans can't respond. And I cannot emphasize this enough, that automation, we've known this since the time of John Henry and his competition against the steam driving train. You know, the automation can slam on the brakes. Automation has a reaction time that far exceeds humans. And one of the things that you can see in many of these accidents are that a self-driving car will be driving, and the human behind can actually see through that windshield, right? So we do this all the time. We see what, in theory, the driver in front of us sees, especially on a sunny day. We can see that there's nothing. And then, but the self-driving car senses something. We don't know what that something is. You can just look at the Tesla crash in the Bay Bridge Tunnel, you know, a shadow. We don't know, and we will not know because of the non-deterministic nature of these systems. But the humans are not expecting, because they can see that through that windshield, they are not expecting the car to slam on the brakes suddenly. The car in front does slam on the brakes far harder, far quicker than a human ever could. And then that's the human just is so shocked that the car slammed on its brakes. We don't have the reaction time that automation has. This is why AEB systems are so critical and are coming, you know, the regulations are coming, so that's happening. But we definitely need, if we're going to be driving around autonomous vehicles, AEB is going to become critical on human-driven cars, because we are not going to be able to respond. We just can't. It's not physically possible to respond as fast as that car in front of us is.
Is there anyone on the panel who's aware of any moves to separate cars that are driven by humans and cars that are driven by robots?
If I may, I would have a question to Missy, because I'm completely in line with you. That's fine so far with your arguments. But the example you were given, when I just imagine, normally when I drive, if the driver in front of me hits the brake, I have the same time of reaction as an automated car will hit the brake, because I don't know why he hits the brake, he just hits the brake in that moment. So this example may be not sufficient enough here, but I get your point somehow. But I don't see any difference between the reaction time if an automated vehicle in front of me hits the brake or another driver hits the brake, whatever he was seeing. I don't know, because I'm behind this car.
Well, actually, I'm going to tell you that that's not true, that the human braking response at best is a half a second. That's just the time that it takes the light from, the image from what just happened to go into your brain for you to recognize and then for you to hit the brake. That's at best. So a half second. A autonomous car, if you have an AEB on, it can brake in less than 1/10 of a second. So it can brake so much faster than you can. It can recognize that closing bearing, decreasing range. That's why I'm saying AEB is starting to become more and more critical if you're driving around autonomous cars, because its perception recognition cycle is far superior to humans in ideal conditions. Now, one of the things that we see is that AEB systems struggle at night. So that is another issue. I think that you are correct in that sense, that now, if we're at nighttime, AEB systems may be more on par with the rate of humans. And so that is likely to become an issue.
Yeah, I'd like to say as well, Missy, I think it comes back to what you're describing as the predictive capability of the car behind that's following the car ahead. And for sure, if I'm driving on a motorway, if I'm stuck behind a van on the outside lane of a motorway, I need to give more space because I can't see in front of that van. Yeah, but when it's a car, then you'll find that the traffic condenses down and everyone follows a lot closer because they're predicting what the other vehicles are going to do based on what they can see in the environment. And it's that mismatch of I see a risk or I don't see a risk. The AV is seeing risks that aren't there, and therefore it's that unexpected braking behavior that causes the issues that Missy was describing, in my mind. That's my own.
Yeah, I mean, and what you just described is defensive driving. And so, yes, yeah. I agree. And I also think that I've also been advocating that we put really big signs on these cars. And indeed, Cruise has done that. They basically tell people in San Francisco, they put little signs on their cars, back up. You need to stay far back from this vehicle. I think the problem is that they don't recognize, I mean, there's some human factors in there. The font of the sign is not that great, and people are not, I mean, you have to get right up on the tail of a car to be able to read this. So, then.
Missy, certainly in the UK, we have a big red L on the back of cars when drivers are learning. And what that actually signifies is that the vehicle in front might have behaviors that you wouldn't predict. The way that they are going to respond is somewhat different to the general population of drivers. And what we're seeing at the moment with AVs, if you look at the examples Missy's citing, is behaviors that the general population of drivers aren't expecting, which is leading to rear end collisions. So
yes, I use that L all the time. I love your L, and I use it all the time in presentations as a nice step forward, because we have to treat them like students.
But that brings us somehow to the point how to indicate an automated vehicle to the other road users, right? So that is a big discussion from the as we had in UNECE by putting a light on the car to show all the other road users this is an automated car. But the counterside of that is that people will start to temper those cars, because as you may know, Missy, in the United States, it's beneficial to get bumped by a car. So if you see an automated car, you will jump in front of it, maybe, because wow, the driver will not get harmed. The responsibility, the liability is on the manufacturer. He can pay that, no problem. So that is a big fear we have at the moment, that cars are getting tempered, and especially because automated driving cars will be much more have defense driving than a human driver for the moment. We are facing the problem that the automated cars will park on the highway just because no one's letting them merge or whatever. So indicating the automated mode, or that is an automated vehicle, to all the other road users is very difficult, I think. Other
Any more
things
thought?
is indicating that to authorities. Sorry, Michael.
Yeah, it's okay. Yeah. Any other thoughts on this topic? It's a very important one.
You know, now that you bring that up, I'm not sure how many people on the call are aware of the incident in San Francisco where the Cruise self-driving car decided to drive through an active fire scene, including running over a fire hose, which is very dangerous. And eventually a firefighter had to break out the window of the self-driving car to effect some kind of communications with the dispatch center. You know, fortunately, no one was hurt and the fire hose did not explode or cause other problems. But I mean, this is a great illustration of exactly what that problem is. You know, the firefighter knew it was a Cruise vehicle, and there's theoretically phone numbers that you can call, but now we're in an emergent scene and the vehicle did not know what to do, did the wrong thing. And while everything turned out fine, it actually could have been quite bad if the vehicle had decided to execute a maneuver while exactly at the same time that the firefighter had broken out the window. And so it's something that I've told the state of California is this is very concerning. You know, you do not want these cars actively actuating if a human is nearby them. And there was another case in the fall of last year where a Cruise vehicle ran away from a police officer that pulled it over. And again, you know, it was cute, funny, but it really could have been bad if that car had actually taken off while the state trooper had his hand inside the car.
And that's the reason why we need some communication to authorities, at least. So authorities may have the opportunity to give an automated vehicle the information that there's a scene that they shall not pass.
So are you saying that all vehicles must have communication with something, and that this something will then have communication with the authorities? I mean, are we going to be in a position where everybody's watching all of these cars just to make sure they don't mess up?
That's not completely correct. So we are now coming to one of the three big issues we have at the moment. It's automated driving, AI, and vehicular communication. And now we are on vehicular communication. So the work in UNECE has already started, thanks to the Chinese colleagues, which are much more advanced with their standards to that. But I think it would be very beneficial if cars will communicate with each other and later on with their environment in terms of other road users or infrastructure.
But at the same time, they're communicated with, but there must be something there that can act on that communication. So we're talking about another level of communication of robot vehicle to robot vehicle, because they're going to be in this conversation as well. Where does the human come in? Maybe Janucci, you can take that subject. Where does the human come in when robot vehicles are talking to one another?
As I explained in my presentation, that the right now the safety driver is the human rather than the AI. So the human should be on the top of the layer of the safety control structure, I think. So and also the other thing, important thing is that the smart city data should be gathered in the one entity, big data management entity, so that they can all the players can share the same information, so the safety can be achieved by using those big data. And also the communication is also very important with the low latency. For example, by using the low Earth orbit satellite system like SpaceX Starlink, those kind is latest, most advanced communications in right now. It's has a big capacity and also low latency, and also they can reach to the anywhere else, any place in the world. If you rely on the cellular communications, you have to rely on the base stations. But if you're in the middle of the desert, you don't have the cellular base station and you have no communication. But if you're using low Earth orbit satellite system, you have the access to the rest of the world.
Okay, I'm going to back up just a bit because it sounds like we're getting into a discussion where AI-based systems, now we're without a human in the vehicle, that these systems can only operate if we have communications. Is anyone saying something different, or do we agree with that proposition, or can we have AI-based systems which don't have communication, which can operate in what really is autonomous mode?
I don't recommend it. I think that there should be, by regulation, a dispatch center. That doesn't mean that there's one person supervising every single car, but I think the issues in San Francisco really highlight the need to be able to have a human attend to a scenario, especially one that's an emergent one.
Okay, so having someone in the car isn't a necessity, but having someone outside the car to interpret what's going on inside the car is a necessity. How is it? Are we going to have somebody driving the car outside and somebody driving the car, or a robot driving the car? I mean, how do we manage this? How does this human in the loop actually get implemented? Any thoughts? Or I mean, first of all, do we all believe that there needs to be a human in the loop? And if so, does that human have to be in the car, or is it acceptable that the human is outside the car?
It's very interesting, the use of in the loop, because it depends in the loop of what function. So when it comes to the dynamic driving task, theoretically, you can't have a human in the loop if it's an automated system. So in the UK regulation, if there's any sort of monitoring or control by a human, whether they're inside the vehicle or outside the vehicle, then that is not a self-driving vehicle. So there's what they call the monitoring and control test. So that doesn't prevent you from having a human that is overseeing a fleet of vehicles, but they have no responsibility, which is more like the dispatcher role that Missy was talking about, but they have no responsibility for the safe performance of the dynamic driving task. And there's a distinction to be made there about, you know, where the in the loop bit is. I would say any fleet operator, most, let's say, modern fleet operators have some form of vehicle telematics in order to monitor their fleets anyway. So there's an ability to extend those systems, and there's no reason why you wouldn't be monitoring autonomous vehicles in the same way as human-driven fleet vehicles. And they have a responsibility for their human-driven fleets to monitor safety as well. So there's no reason why the fleet operator wouldn't also be monitoring the safety of those autonomous vehicles. And then in that case, making a comparison of the safety of their autonomous fleet versus their human-driven fleet. And I think that's what's going to be really important as we move forward.
Sorry.
Is anyone familiar with an OEM that has currently that is monitoring all of its vehicles remotely?
Waymo.
They're not an OEM.
Oh,
Waymo's something else. They're in a test mode.
You could say GM, you know, they already have the Super Cruise ability, and I'm not 100% sure. I mean, I've been inside Waymo's dispatch center. I hear that Cruise has something similar, which I presume leverages some of GM's technology, but I've not physically been inside their dispatch center.
Mm-hmm.
And GM have something called OnStar, Michael, for their human-driven fleets. You know, again, it's seen as a value-added service if you're involved in collisions. But effectively, that gives them the ability to monitor those vehicles while they're performing in the real world.
But my question is, do we know? I know for sure that GM is not monitoring their vehicles with OnStar. I know that Volvo is not monitoring their vehicles with Volvo On Call. I know that most of the OEMs are not monitoring their vehicles 100% of the time. They may be collecting data. They may be able to do a post-event download of data, but they're not monitoring their vehicles. So that if the driver gets into a fix and can't get out of it, there's nobody there that says, oh, I can help you out, whether it's OnStar or any one of these other systems.
Yeah, again,
we've mentioned
sorry,
Tesla
Jenny.
a number of times. Yeah, Jenny, do you have a?
Jenny was going to come in.
Yep.
Sometimes we discuss the possibility to not have the human in the loop as a monitoring person all the time, but you can bring the human in the loop when necessary.
Mm-hmm.
If the system cannot operate totally on themselves all the time, and sometimes they might need support. Like for remote, or if an object is on the road and the vehicle has a problem determining what it is, if it can continue or if it has to stop.
Mm-hmm.
And stay there. And also sometimes maybe a self-driving car must go over, what do you say, override traffic rules. And they shouldn't really be able to do that, at least according to the type approval requirements.
Sure.
They shouldn't be able to override the traffic rules. But in that case, if necessary, a human can be brought to the loop and decide for the vehicle in order to maybe move the vehicle or cross a line or something that is really needed.
And that's what Janucci showed in his presentation. I mean, the standardization working around the fact that they're going to bring a human into the situation if necessary. Okay, I'm going to switch gears, change gears. Bryn, you've been working in this area for quite some time. You've had cars running around with nobody in them around tracks. Can you give us some examples of AI-based applications that are being used today?
Yeah, I think it goes back to the definitions of AI, and it's interesting that Jan obviously had a definition of AI. I think everyone can define AI slightly differently. I kind of like the German sort of data and ethics commission view, which actually they stayed away from the use of AI and just focused on algorithms. So it's just algorithms that are being used. And for sure, what we were in the RoboRace context, which is slightly different to what we do now, where I work at Oxbotica. So at RoboRace, most of our high performance drives, we set the world record, for example, I think it was 186 miles an hour in an autonomous vehicle, no human on board. The majority of that focused on data that was coming from the highest performing sensor in terms of localization and the best in terms of heading of the vehicle. And that happened to be a GNSS IMU approach. So we were using algorithms attached to that in order to then optimize for speed and orientation, but particularly around the racetrack was then optimization for racing lines. So that was more of an optimization problem. What you had in that, in the initial work that we were doing, didn't involve perception, because you were being told where you were, and we had vehicle-to-vehicle communications that would enable you to be aware of other objects. Where I've moved to now, which is in Oxbotica, where we deploy autonomous vehicles or autonomous vehicle software in a number of environments, both on-road and off-road environments, you'll find that AI gets used more on the perception side. So when you're actually detecting objects from the sensor data. So that's really where it's coming and where I see it's being used. More and more it's being then used on the predictive side as well. So motion prediction of other agents in the environment. So they're the two key areas that we're seeing AI being used.
Can anyone else identify some actual actual applications of AI in the field today?
As far as I know, but it's out of the safety safety relevant things. In vehicles, there are used AI applications for speech recognition. But yeah, that's
that's an application. Yeah.
Yeah, absolutely.
Yeah. Sure. Okay, so we're talking about automotive artificial intelligence, but we're looking at it in terms of future applications, not in terms of specific current applications. What about the Mercedes-Benz automatic lane keeping system? Are anyone familiar with those systems to the extent that they're using AI, or is it just software, data management, data processing?
According to the antitrust law, I'm not I'm not aware on that. Because I'm not working well. I know the colleagues well, and I was participating by writing the UNR 157 somehow. But I know that there are the first manufacturer coming out with an LKS system where we have the strict separation from what we in this discussion mixed a little bit up with assisted and automated driving. So in this system, it is the first system on the market where the driver is allowed to be hands off, minds off, whatever, but needs to take over the driving task as the system asks him to take over. But there's a minimum time that the driver needs to have to find out where he is, what he is, when he is. So at least it's 10 seconds that he has to take over the driving task. So that is we know from the system from our colleagues from Mercedes-Benz. And as far as I know, there are not many issues for the time being with it, but I don't know any times of usage for that. So
okay. I've got a question for Jenny. How do automotive AI applications affect data privacy?
Well, since they may rely on the collection and processing of large amounts of data from sensors and cameras and connected devices and other vehicles, maybe. So this data can also be personal and sensitive. It can be location data and data on driving behavior, such as speed and braking and in-car behavior. And this data can be used to identify and track individuals, vehicle occupants, and also people in the surrounding environment of the vehicle. So, and as more vehicles become equipped with different AI systems, more personal information is probably collected and processed by these systems. And there's a reason for that, because it can improve the driving experience and safety, and also provide valuable insights for automakers and also service providers. But this also raises privacy concerns. For instance, risk of unauthorized access if not adequately protected. And it can be a risk for misuse, and that the data could be used for other purposes than the driver or passenger intended or is aware of. There can be also a lack of transparency, that the person concerned doesn't really know or isn't aware of the data that is being collected and how it is used and who it is shared with. And this can also make it difficult for them make informed decisions about their personal data.
Mhm.
So there are a lot of risks regarding personal data, but there are also things you can do to mitigate these risks. Also, both the provider of the AI system can take some actions and design these systems with data privacy in mind, and there's also the regulatory framework has also a role here. It can help to ensure that data privacy is protected during development and also deployment. For instance, the GDPR regulation in Europe, which sets requirements for organizations to handle personal data. And there's also an upcoming AI Act in EU that will also set requirements and also ban certain applications. And it puts different AI applications in risk categories, and some of them have an unaccepted risk, and those will be banned. And
such as, for example,
social scoring systems, for instance, they will be banned. And there's a list actually with the applications, and it's not. This is a proposal, so it's not a ready framework. And there's a risk category that is high risk, and they should be CE marked and to be compliant with all EU regulation, not only the AI Act, but also other relevant regulations. And then there are also the category limited or no risk, and they are pretty much unregulated in this proposal. But it's something to keep in mind, that the framework is evolving in the EU.
I think what's interesting, Michael, is that I think even Jan mentioned ChatGPT, it's like the public's exposure to AI applications is growing, and it's very interesting, this potential for a horizontal approach to AI regulation that just builds trust in AI systems generally, whether it's deployed, in a business environment, a banking environment, a government environment, whether it's for healthcare, whether it's for autonomous driving. That need to have transparency or explainability exists horizontally. And then it's very interesting how those expectations then start to impact industry verticals. Now, at the moment, the AI Act doesn't apply to existing regulation for motor vehicles, but it should be taken into account when implementing or delegated legislation under the existing acts. So there will be some changes that are coming, and things like for high-risk systems, and you could argue that vehicles fall into the high-risk category because they actually have the potential to cause fatal harm. There's a need to report occurrences, and occurrences are things like high-risk events that have happened, like collisions or near-miss events. And those things are now coming into the sort of UNECE type regulation, and certainly then for the EU regulation. So the recent European Commission regulation from last year includes in-service monitoring and in-service reporting, and a requirement under those things to report occurrences, which includes near-miss events.
Yeah, well, let's take that example.
Yeah, go on.
Let's take that example of a near-miss event. I'm driving. I come to a crosswalk, and I've slowed down, but suddenly someone appears that I hadn't seen on a bicycle, right? And decides to use the bicycle crosswalk. Decides to use the crosswalk as a bicycle path and turns immediately into the bicycle, with their bicycle onto the crosswalk, and I need to brake very, very quickly in order to miss this. This event is an occurrence in your terms that goes someplace. It's a near miss. Is it on me? I mean, if I've had 5 of these near misses, right now nobody knows about them except myself if I'm in the car by myself. You know, maybe somebody's watching that knows it's my car, you know, at least in one of them. But I know that I should have been more attentive, but it's not going into some, you know, public database that says Michael Senna had 5 near misses during the week of the 13 March.
It's not unless you've got telematics-based insurance, or unless you're driving a fleet-operated vehicle where that data is being collected and reported against from a health and safety regulation perspective. That type of information is being expected from automated vehicles, so that will get reported. And then I think one of the interesting things that you're raising there is, well, how do you make the comparison of how safe AVs are compared to assisted driving vehicles? And I think that's going to be an area of increasing interest for governments as we go forward, where they want those types of occurrence-based evidence of safety performance. So not just fatality statistics or serious injury statistics, but getting down more towards the actual driving behavior. So I think that's coming. We're not there yet, but it's definitely something where in the ITU work, we've set up a communication framework, and everything you described was really the world model representation. Where were the actors in that event over space and time, and what conflicts resulted. That is what we've set up with the ITU work that we've been doing in the focus group. So it provides the foundation for the type of analysis that you're looking for going forward, and also the type of event identification, because at the moment there is no agreed definition of what a near miss actually is. And there are various different ways of calculating that. My preference in particular is sort of post-encroachment time, or at least a sort of a distance-based, speed-based measurement. So, but that's just my personal preference, and that was sort of one of the key things that came out of the focus group as a metric that can be used after the fact. So not a predictive metric like time to collision, which is predicting events, but something that actually looks at, how close did you come? If the vehicle was there and you passed after that vehicle had passed, what was the time gap between you being in the same space as that other vehicle? If the time gap's 0, it's a collision event. If it's less than half a second, yes, that could be a near miss. If it's less than 3 seconds, is that a near miss or not? Who's defining that? And that's what needs to be done in the industry.
Any further thoughts on this? How does this information get processed and used and put into an effective form so that the vehicles that are driving without a human at the wheel are able to use this information? Or is that something that we can't even think about happening? I mean, if cars are sending near miss information, what's being done with it? How do we see it eventually coming into the entire process of updating vehicles so that they are more capable of avoiding accidents?
I think that's one of the big challenges, Michael, and it is the volume of data. So if you look at the accident analysis that has been done in NHTSA, or if you look in the UK, it's large-scale collision events, or serious collision events, or important collision events. The number of near misses that are occurring on a regular basis is, I don't want to exaggerate, but it's many times higher than that. And there aren't the data processing infrastructures in place to deal with that within the governments or regulators. So this definitely feels like something that will be done inside fleet operators in the way that they're currently doing with telematics and extensions of that, or within the AV developers, and then reported again. But I don't know, Missy, if you want to come in.
Yeah, I just want to jump in and say, it's still like the definition of what is a near miss is hotly contested. you know, depending on the geometry of a scenario. But we do know that these phantom braking or hard braking events, you know, these definitely, there are much more clearly defined potential near miss, right? So you almost got rear-ended. And so I advocated inside of NHTSA and continue to advocate quite strongly in the United States that at least in testing scenarios, if there's any permits that are given to any car, truck, whatever, that hard braking events less than -0.5 G should have to be reported to some kind of governing agency, because that clearly represents, if it doesn't end up in an accident, which often it does, but the risk was very high that could have been. So that, I think, is a much more clear near miss metric that will also give regulators at the federal and state level a much more clear picture of how perception systems are performing.
Mhm.
And so I think, I'm not saying that should be a permanent requirement, but at least in the next few years, I think if we had hard braking data submissions from all manufacturers, including ADAS, we would have a much better idea of what's going on.
Yeah, and I think what we were looking at, Missy, with our work is being able to use the harsh brake as a trigger for then data recording. And then what you want to know is what was the situation at that point in time? What was the world model that was being used to give you a little bit more inference about what was going on inside the AV itself? Now, at that point, you also want the AV software to be recording much more data, which relates to all of its raw sensor inputs, in order to assess, well, how did it get from the raw sensor data into that output that led to a harsh brake? And that isolation, if you like, between a quite lightweight world model representation that's in a common format that could be shared by all vehicles, and is shared if you use one of the ETSI standards for cooperative connected automated driving. That type of lightweight protocol works really well for a regulator. The high levels of data, if you look at the volumes of the data, the frequency of the data, all of that that's related to sensors, that's really the domain of the AV developer, because it becomes so proprietary to their system and their system design. So that's very hard for a regulator to access that type of data. Sorry, Jenny, I saw your hand was up.
Oh yeah, I would like to make a connection to something else we have seen in some research project around autonomous vehicles, that they know the traffic rules in their ODD, and one rule that is problematic for them, as we have seen, is the priority to the right rule. I'm not sure if that's the correct term. The
yield right.
Okay.
Yeah, yield right.
Yeah, and the autonomous vehicle get it right every time on this route. But sometimes the traditional drivers, they don't know that this is the rule at that place. So there's many near accidents related to this, and in this mixed traffic between traditionally driven, manually driven vehicles and autonomously driven vehicles. I'm not sure if that's another discussion, but
this is absolutely a very important issue. In Sweden, where Jenny and I both live, we have roads that have a yellow diamond, and those roads are priority roads. And if I'm driving on that road, any road that's coming into that road from the right or the left has a rule that should be followed. If the car is coming from the left or the right, if the car from the left wants to go across, or if the right just wants to come in, they do not have the right to do that. So most roads coming in from the right will have a yield sign. most roads coming in from the left will have a stop sign. If I'm in the middle of Stockholm, where there are no yield signs and no stop signs, and I don't have this yellow diamond on my road, the car coming in from the right has the right of way. Whatever that car wants to do, turn left, turn right, go straight, that car has the right of way. I must stop. A car coming from the left can make a right-hand turn unaffected by me, but if he wants to go straight or wants to come into my lane, that person has the right of way and I must stop. So you've got to know, if you're a Swedish driver, you've got to know if you're on a road with a diamond or not. Usually, wherever this situation occurs, there's a sign that says, that reminds you of these sorts of things. All of this doesn't exist in Scranton, Pennsylvania. I can tell you that for sure, or in Boston, Massachusetts. It doesn't. I don't know if it exists anywhere in the United States where there's a, you know that this road is a priority, and you know that you have right yield and so on. All of this needs to be put into the systems. And what Jenny is saying, people know what they're supposed to. They all did their driver's license test. They all went through the test, and believe me, I went through it when I was 45 years old, and I flunked it twice. So I know what you have to know. And one of the things you got to know is who's got the right of way and why. They just don't, they ignore it. So what do? If somebody does something that I didn't like, that was clearly against the law, I flick my high beams. I may even beat my horn, which is, a sin in Sweden. How do we deal with these sorts of things when we're in driverless mode? Are these the kinds of things that we have to make sure that we plug in? Because if I go over to Norway, it's different. If I go down to Denmark, it's different. If I get on the ferry and go to Finland, it's different. Or Germany.
I think if we talk about fully automated driving cars, it would be much appropriate to have all the traffic laws digitalized, so you do not have to have the signs around you and to believe that they are the correct signs. No one was no sign is dirty. No one was removing this sign. Whatever can happen. So you don't, as a driver today, you don't know what to do in this moment. Mm-hmm. So and that is a big issue and a big task we have to do for the moment. That there are big discussions between the UNECE WP1 and WP29 on how to have a digitalized traffic routes.
Let's see. Digital traffic rules.
I didn't realize that question was for me. I mean, I'm a big, when we talk about connectivity overall, I'm a big fan of having traffic devices communicate in advance, in some way, because, for example, you can get great fuel efficiencies if cars can learn to moderate their, acceleration, deceleration to potentially. As far as safety goes, I think it's fine as a nice to have, but that should never become a replacement for the onboard ability of cars, trucks, autonomous vehicles to be able to see the world around them, just because there are just such huge problems with reliable and predictable communication networks. I mean, this kind of goes back to why I'm so anti-remote driving. Can you do it? Yeah, you can do it in some cases, but as soon as the network gets clobbered, no. So big fan of digital connectivity. It's a nice to have, but not a must have.
But what about onboard? I mean, loading the cars. I sell a car in Sweden. I sell it all over the EU. I sell it, in the United States. Wherever I go, that car will have the rules of the road. So it knows, look for the diamonds. Am I in a diamond area? Am I not in a diamond? All of that's downloaded.
Yeah. I mean, that's what I'm saying. It's like, assuming that whatever that knowledge is on the car and doesn't have to rely on any external connectivity. So that's what I mean. It's like, you know, I mean, that's how self-driving cars do it. They have the models, they have the neural net vision models already loaded on the car. They already know what to look for, right? They don't have to have any kind of external connectivity to recognize the yield signs. You know, in theory, geofencing is already on the vehicles. The only time I get concerned is when anyone thinks that there's any kind of real-time connectivity. And by the way, these cars are not learning in real time. No learning ever happens in real time. So, you know, it's that external connectivity to access a piece of safety critical information that should never be allowed.
Michael, I think it's also interesting. So in the context of road rules, because as Jan pointed out, that now sits across two different areas of the UNECE, because road rules has traditionally been WP1 and the conventions on road traffic, and they apply to human drivers. And now there's a question of it similar that I think Missy raised earlier. Well, okay, but how do those road rules apply to automated vehicles? And at the moment, the new article 34 bis that was added to the Convention on Road Traffic actually excludes all automated vehicles from compliance with any of those international road rules. And it does so on the basis that there will be new technical regulations for automated vehicles, and then new regulations, and they can be domestic or international, and then new domestic regulations for approval for use of those vehicles. So it's very interesting that we had an agreement on international road rules. It won't go down to the specifics that you mentioned about diamonds, if that's not an internationally agreed standard, but there are behaviors in there that are the norm for all drivers everywhere. They are what enable me as a UK driving license holder to go over to the US and drive, or to go to Australia and drive, or to go to Brazil and drive. Now, that's what gives me that legal right, if you like, international authorization to go and do that. And they are those behaviors that I think become really key, that need to be the foundation inside every automated vehicle before you get to the level of discrete road rules in a particular domain. Yeah. And I sometimes think that those additional rules are there just to sort of, in some ways, assist with the correct behavior. So like when we were working with on the focus group, we always had a question that came up about whether the mechanisms I've said about this world model detection would show whether the vehicle had passed the red light or not. And actually, there's something more fundamental than that. That's a rule. You know, you mustn't pass red light, fine. But there's something more fundamental than that, which is, if it did pass a red light, did it end up in a conflict event with any other road user? That is the safety issue, if it ended up in a conflict. So in some ways, it could be that you passed through the red light, there was no one else there. Actually, there's no, in that case, event that was detected. No conflict event, because there was no safety conflict event.
But he went through a red light.
But there's no safety conflict because there's no one else there. It broke a road rule. There's no safety conflict. Now, you would also then go back and say, okay, but that's a leading indicator. If I've missed a red light and there was someone coming through, then that's going to be a much higher likelihood that I could have a collision. So we're not saying ignore that data, but we should also always focus on the fundamentals, which are the road conflicts and the exposure to harm. They're the things that need to be captured first, and then you can layer on top the interpretation with road rules. That's the way
I'm going to fight with you, Brent. I mean, I'm going to say I totally disagree with that. I mean, you know, because we're seeing this now. I mean, this is a problem now that cars are flying through red lights, and you know, just because you fly through a red light and nothing happens doesn't mean that it's not important. I think I could see what you're talking about if we were like 5 to 10 years down the road when we have more mature systems. But missing a red light is a clear signal that there is a defect in the perception system. So 100%. In my mind, that is a huge red flag right now that has to be dealt with right now.
But what I'll do is I'll flip that on its head Missy, and say, okay, it's great to detect red lights, but once you've detected a green light, do you proceed across that junction blind to all of the other road users and assume I have priority, I have right of way, therefore I don't need to look at what the other traffic is doing because they're being held on red lights. And that is where you lack situational awareness. And so the conflicts that Michael was talking about and Jenny was mentioning is really about perception of how are the other road users driving relative to me. And that's the thing that you need to look at.
Yeah,
well,
but
that's the fundamental behavior. So the red light is a rule-based behavior. You want to look at the fundamental behavior, which is interaction of objects.
I hear you, and I'm about to drop into the chat a paper where I talk about exactly these things, like, but you first must have the ability to execute the rules of the world before you can start to bring knowledge-based judgment under uncertainty to the world. And so I totally agree, you know, just because you have a green light doesn't mean that you should proceed through an intersection. Indeed, this idea of being a slave to the rules, I think self-driving cars right now are really kind of squarely in this spot, is that they will execute decisions based on rules before they actually have what you're calling situation awareness, a better understanding of the world model, a realistic world model. And this is where I would hook in the defensive driving capability that is simply just missing.
Yeah, in a pre-postmodern world, I'd come to a green light and I'd proceed. In a postmodern world, I come to a green light, I slow down, I look to the right and the left, because a postmodernist could be coming right through that intersection who says, rules aren't for me, rules are for the other guys. They're dumb, they pay taxes, I go through red lights. Who's programming our AI systems? Are they postmodernists or are they pre-postmodernists? Okay.
I think that thinking is too highbrow. They are just desperately programming to get more venture capital funding.
We can discuss that. I think we've had that discussion a number of times, and I think we're on the same page on that. Can we take a vote of the panel? Who thinks that government should be regulating automotive artificial intelligence? Just raise your hand if you think the government should be regulating automotive artificial intelligence. Is that a yes, Bryn, or is that just?
Yes, a raised hand for saying yes.
That's a raised hand. Yes.
If you say
Missy,
yes, there should be some regulation for it. For sure.
Yep, that's a raised hand. Yep.
I want to raise a half hand.
You want to raise a half hand? Okay. Okay.
Because I would be it would be most likely not separate regional governments will regulate that, but we're doing this on a harmonized way, on a harmonized basis. So that's the half hand. So we need something that sets barriers to AIs, definitely. But it should be, if somehow possible, the same worldwide. That's the
worldwide view. But we don't, unfortunately, we don't have a worldwide view. Janucci, what do you feel? Do you think that government should be regulating AI, or that the market should be regulating?
Yeah,
AI?
I think the government should have some kind of regulations put in place first in the deployment, because in any case, anywhere the bad guys coming in, if there is any gap in this safety issues or security issues, so the some kind of regulation should be put in place in the first place, so we can avoid any unexpected situations.
Am I correct in I just want to clarify a point. Junichi, am I correct in saying that Japan is part of the type approval process?
Yes, the vehicle is or has to be type approval, like UK, Europe,
Yep.
But the United States, I heard that the United States OEM has to approve by themselves on the vehicles, right?
Yeah.
So the
Yeah, but that's
quite
kind of that's a little bit of a misnomer, because the U.S. does have a set of specifications. Even though they say we meet these specifications, the OEM has to do the tests themselves as opposed to having a testing agency. And I think that's the main difference. Missy, are we in agreement on that, or do you see it differently?
I mean, there's what I personally want, and then there's what's like what is achievable. These are since I don't get to be the king of all things self-driving, I wish, if it were up to me, we would have type approval before any of these cars hit the road, self-driving ADAS. But it's not I think what would be achievable in the United States is what I talked about before, is self-certification, and this initially, and then as problems start to emerge, once a recall happens, then type approval for, and indeed, we need to have that discussion about any over-the-air update that touches safety critical systems. Can our companies, do they have a strong safety culture? Do they have the tools that they know to do a risk assessment that what they've done is at least not going to introduce new problems? I think this is one of the things that we're seeing. Like, first, if you're going to do an OTA, it has to address the defect. And then secondly, that you didn't cause another problem. That's still a big question.
I think what's interesting, Michael, when we talk about the regulation, we all put our hands up. It's then where that regulation line is drawn. I said we all put our hands up. We didn't. It was a half hand. But where that regulation line is drawn. So I think, Missy, if I'm correct, when you mentioned the sort of standard general order and the information that was being withheld as part of that, I believe that information was related to the threshold of how safe is safe enough. How were you able to determine whether that vehicle should be deployed on the road or not? And that is at the moment being seen as like a competitive advantage, is who can define where that line is. And you could have a utopian view, which is people are setting that bar very high, or a dystopian view, which is it's as low as practically possible to actually start generating some revenue from that service. And at the moment, that threshold isn't really being defined anywhere. That is being left to the market, is my understanding. Missy, I don't know.
Yeah. So I mean, there are two things. I agree with what you're saying, is that companies are determining what they feel like is good enough. And I mean, that's a different discussion. When I was referencing the standing general order, what I meant was not that decision. What's being withheld from the public is many companies claim, if you actually go look you can go see the publicly available standing general order, inside the narrative section, some companies just claim the entire narrative of what happened is confidential business information. And I don't think that should happen. I have not ever seen anything claimed to be confidential business information inside the SGO that was what I thought would pass a legitimate test for confidential business information. So I think we need to revisit what a more clear definition of confidential business information is, and whether or not the details around how a car went flying off of a road, whether that is in the public's interest to know that.
Okay, I was thinking that, so it might be then I was thinking of the approval that was granted for automated operation. And within that, you have to describe how you believe the vehicle to be safe. And then there was a lawsuit that prevented that information being released to the public. I don't want to name names. I'll have to go back and I'd have to look that up.
I don't know where you. So in the United States, if you want to, you do a voluntary safety assessment. You don't have to do one, and you don't have to publish it to put your cars on the road. I mean, they're called VSSAs, and you don't have to do it in America. So I mean, this is actually part of the issue with, if it's not even an approximate type approval. companies just do it if they want to. And I have been very critical of all these voluntary safety assessments. I have yet to see any company actually produce any hard data to demonstrate that they have indeed achieved some kind of minimum threshold of safety. So when you talk about that threshold, I agree with you, but companies are the magic sauce, the secret sauce behind why a company decides it has crossed a threshold from testing to driverless operations. That's true for Waymo, it's true for Cruise, it's true for Neuro or whoever. Like, we don't know why they made that decision. And I'm sure that they're never, that's never going to come to light. I'm not saying it should, but we also have no guarantees that indeed due diligence was done.
Yeah, it was actually Waymo, and it was California Superior Court in Sacramento that actually then blocked information Waymo had shared in order for them to get their license from becoming public domain, because Waymo said it was proprietary.
Okay, so that's a state permit process.
Yeah, that's a state permit for them to do automated operations. So I just looked that up. I didn't want to mention names without actually double checking, but I just found that really interesting because it spoke to what Missy was talking about. I think where we should be working collaboratively to kind of define what those standards should be.
Agreed.
And at the moment, we're in that opposite mode of really protecting all of that information as if it's competitive advantage. Yeah, and I think that's the big shift that we need to see in the industry as it matures.
Now that gets back to the question I asked of whether or not there's an organization where people can get together. The problem we have also is that we have, both in Europe and in the United States, we have authorities that are trying to ensure that there's no complicity, there's no collaboration that might go over the boundary of what rules are in place for competitive behavior. So we have the Federal Trade Commission and the Department of Justice, who want to make sure that we don't, ensure monopolies, and we don't have groups who are colluding. And unfortunately, I think this oftentimes gets in the way of people sharing information that they could actually use to help one another be better, as opposed to just being, just helping friends.
I think. Oh, sorry.
Go ahead.
Yeah, no, I was just going to say there was another interesting point about where you draw that line in regulation and where that could shift responsibility. So there was Intel Mobileye have their, I think it's responsible safety something, RSS basically, but and that was turned into an IEEE standard, and we worked with that standards group as we were developing the focus group activity. And what's interesting, Michael, is that becomes, like say, an algorithmic approach to assure safety in the behavior of the vehicle. So the algorithms are there and they will influence the behavior. The intent is that you can be 100% safe in the way you're driving. So that's according to these deterministic rules. But what's really interesting is those rules are then based on a set of assumptions. And those assumptions are based on, well, how are all the other drivers driving, and what's reasonable for me to assume about all the other drivers. And in some ways, what some AV companies were interested in doing was having that defined as the standard to control behavior, because they could measure themselves against it, but having the governments define what those assumptions should be, what those values should be. But what that means is that you've suddenly shifted that burden away from the AV company into the government. So if there is a collision event, it's like, oh, but sorry, the assumption numbers you gave us were wrong.
Yeah.
That we did the calculation and we did mathematically, deterministically sound calculation. We can prove that we did that, but unfortunately the numbers you gave us were wrong. And that's very interesting. So then the governments start to feel a little bit more exposed and push back a little bit and say, no. We will regulate, but we're not going to regulate to that level, because that's your liability, that's your risk. And so that none of that's been solved yet. It's not been agreed yet internationally, but they're the sorts of discussions that we've seen taking place.
It sounds to me like these issues are being addressed. Janucci, Jan, you presented, and Bryn, you presented standardization work that's going on. These
Regulatory
areas,
work. Regulatory
regulatory,
work.
regulatory and standardization combined, regulatory and standardization work. Because I think that the regulatory is important at this issue, that once you have all of these organizations which are developing standards which are not compulsory. I mean, ISO is not a compulsory standard. IEEE is not a compulsory standard. ETSI that comes up with certain things, they're not compulsory, but when it gets into UNECE, when it gets into a UN, it becomes compulsory because then it becomes part of the law. And that's really an important distinction. We're getting close to the end. There's one question I want to make sure that we do address. Are there any areas of research that we feel, I think Jenny and Missy on this, are there any areas of research we feel that are being neglected, that we can say to all the folks listening right now, we should be doing more here? Jenny, can you think of any areas where research is missing?
Oh, there's so much research missing, I think, in this area, because AI is rapidly developing, but there is so much more to do. There is room for improvement for those functions already developed and or that are on the way, but also around many issues that need to be resolved in order to build trust and acceptance. For instance, security and privacy and transparency and ethical aspects. And also, since the AI regulation is upcoming, and we also in the EU have the Data Act coming and Data Governance Act. The issue of legal compliance with these new regulations, where are there uncertainties, and where do we need more clarification, and also policy development. It will continue. And there's a lot of different areas. For instance, regarding privacy, we have a research project at RISE that develops algorithms to replace personal data collected in real traffic environments by creating anonymized and unique faces that are totally made up. They don't exist, but they look very real. And this we can use, and no personal data is stored. But there's refinement to make in these areas. And transparency, I think that's a big issue for safe critical applications like autonomous vehicles, that it's important to be able to understand why the system made a certain decision in the event of an accident, for instance, that we can explain this and be transparent about this. And robustness, reliability, cybersecurity, there's very much to do. And also, Missy was talking about the role of the human driver and the machine-human interaction. How can this be safe, the human-machine interaction? So all in all, there's much to do in the research area, I think.
Missy, do you have
a
long list for all your students to say? Yeah.
I actually made a list for NHTSA as I left. I'm like,
yes.
Gigantic. Like, these are all the things that need to happen. But just to keep it short and not be here all day, I'll say 3 areas: latency. We need research on what is the latency, because latency is not just one thing. It's not just the cell network latency, for example, or a lot of companies are using triple cell networks. It's also the human is part of that latency. If you have a remote driver and there's latency in the system, and then the remote driver was texting on his phone right when that problem happened, and you've got double sources of latency. So we need a lot more work on the technical aspects of latency, and also standardization around latency. We need a lot more work about drivers in other cars around self-driving cars. I think people have heard self-driving and they're like, okay, well, because there's no human in that car, we have no issues with humans and we don't need to do any human factors research. And now we have a whole emerging set of problems around the other humans inside the ecosystem. And it's not just drivers, it's bicyclists and also motorcycles. I mean, we've seen several crashes involving motorcycles and autonomous vehicles. And so I think there's a lot of perception work to be done. I think there's a lot of work to be done on the human aspect. So, and then there was a third area that of course escapes me that I was thinking about. If I think of it, I'll come back to it. But yes, I mean, perception, humans, latency, big areas.
Any other thoughts before I ask drop in the last question here? You haven't seen it, so it's going to be a surprise for you all.
I mean, obviously, 3 years of bias towards explainability and the work that we did at the ITU focus group, full transparency. So seeing that work now being transferred to become an ITU recommendation, seeing that being adopted or referenced within global regulation for automated vehicles, that's something that I think would be really positive for the industry, if I'm being honest.
Yep.
At the moment, there's no format in which data can be shared from a manufacturer to a regulator in a standardized way for the types of things you were describing. You know, where were the vehicles and how did they interact with each other? And vehicles being bicycles, motorcycles, pedestrians as well. You know, it's like those road users. So finding a standardized way to communicate that, one that aligns with connected, not cooperative automated mobility, one that aligns with smart infrastructure in cities, that would really harmonize road safety in the sort of, let's say, in the high income countries where you have access to those technologies at the moment, not in the low income countries. That's my bias.
Shinichi, have you any thoughts on further research that that really needs to be done?
I think the security credential management system kind of thing should be in place. Also the regulations and also research work, and also the experimental tests on the road. Those kind of the things, because of the big data is coming in the vehicle, also coming out from the vehicle. It's communications security is very important, and also the security of the application services is also very important.
Yeah. Okay. Jan, last word on the research that needs to happen. You're muted. Okay.
That's due to a double mute I have to do with my phone here. Sorry for that. I think there's already done a lot of research, and we still, as all my colleagues just said here, there's a lot left to research, but we should somehow start to use it as well, so that we find the best application for any AI in automated products or in automotive products. So there's a lot of research to be done, but we somehow should start as well to use small and not safety related AI applications and algorithms to get some real world data from it, to learn even from that, not only do research from the scratch or on the desk, so that we learn from real world issues as well.
Okay. Any last thoughts? I'm going to hold my question that I had, because there's probably not enough time to answer it. But any final thoughts before
Real quick, I remembered what I was going to say. Yes,
Yeah.
we need more research on more efficient testing of non-deterministic systems.
More efficient testing of non-deterministic systems. Okay, good.
And I can also add, because someone mentioned smart city, AI in smart city context. I was thinking about the system boundaries between vehicles and traffic systems, and which rules will be applicable, and the liability issues. How do we define that between traffic systems and vehicles if safety components are integrated in the road traffic management or in the vehicles? I think that is also an issue to be resolved or looked at.
Yeah, I had a few questions here on liability, but we've come to a point where we're close to the end. And before I hand it back over to Stefano, I want to thank all of you for the time that you've put in over the last 6 months since we started this process together. You've been terrific. I mean, I've really, I couldn't be happier with the involvement, engagement, and the participation that you all have. And I think it shows in the discussion that we have. I hope all of you who are on the other side of the screen can also feel the same way. I hope so. So Stefano, I'm going to ask you to come in. I want to thank you and all of the people who have organized this, Ifti and all of the team, Selena, Ginu, and everyone. Thank you for all of your assistance.
Thank you. Thank you very much, Michael. Actually, today's session was really interesting. I've learned really a lot. I'm sure everyone did. And I wish to also thank a lot our keynote Missy, as well as our panelists, Junichi, Jenny, Jan, and Brian, of course. This was really a live, interesting panel discussion.